Hi everyone, in today's video we're going to just talk about stock forms of materials. Now this isn't on its own quite a large theory. Typically this would be, if you imagine you got a 3 or 4 part question, so an A, B, C, D or an A, B, C, D, E, the main part of the question might be, for example, showing you a children's plastic toy or a wooden toy. It might ask you uh, what material would be appropriate and why, then ask you about the manufacturing process, and then it might ask you the stock forms that it comes in. So on its own, it's not a large series, there's not a lot to cover, but it's important to consider that it is normally part C, part D of a question sometimes, so it does come up, so it's important to make sure you've got the core knowledge. So basically you need to know what the term stock form means, and then what the stock forms of woods, metals, and paper are as well. So more information for these will be done in each of the theories, specifically for timbers, metals, and papers, but these are sort of the generic stock form terms. So timbers. So obviously you've got three classifications of timbers. You've got hardwoods, softwoods, and manufactured boards. So hardwoods typically are sold by the cubic meter. So you can then have rough sawn, which cuts your size. So that's if you go to like a timber mill and they are put through a giant table saw. And rough sawn means just that is they're rough sawn. They're not like planed all around or anything like that. And they can be machined into dowel, which is the tubes, non-hollow, so the solid tube of timber that you can get. They use like dowel joints and things like that. So softwoods are supplied in the standard sections, so 1x1, 2x2, 2x4 sheets of timber that you'll typically get. You can get rough sawn again, like hardwood. So as I said, that's going through a table saw, and it's done that way. Or you get plain smooth or planed all around, which is PAR, and that means it's been rough sawn, but then it's also then been put through a planer thicknesser to get rid of the fibers around the edges, so it is smooth all around. So that is ready straight away for construction. So typically, if something is just rough sawn, it needs to be treated a little bit. It needs to be like tidied up to be ready to be used. But rough sawn does typically come a little bit uh, cheaper. And then manufactured boards. So these are supplied typically in imperial measurements, so feet and inches, and they come as boards. So if you buy a sheet of MDF, a sheet of plywood, a sheet of hardboard, things like that, you get by 6x4 foot sheet, for example. Um, and they come in a variety of thicknesses depending on what you want. So obviously, if you're going to buy, say, something to be laser cut, you can have like a 3mm sheet of MDF that is 900 by 600mm, and you know that's going to fit into the laser cutter. You can go from 3mm, 6mm, 9mm up to like 25mm. I've had students that have made like bits of furniture and they've used like 25mm plywood, 25mm MDF that are very dense, very heavy. But the benefit of manufactured boards is that you can get them in huge sizes ready, whereas obviously natural materials, you're limited to the size of the tree that it came from. So typically, if you're going to get some natural timber, but you need to cover quite a wide surface area, you're going to have to join the material together. Now, typically that will be done through biscuit jointing, where you cut a little groove with a biscuit saw, and then you put material inside it, glue it, clamp it that way, which looks nice, but is a natural weakness because it's a join. Whereas typically in things like construction where plywood's used quite a lot, you know it's one solid piece, it's the size that you need it, it's a lot more convenient that way. So just on the right hand side here, just kind of clarifying a bit more about rough sawn and plain. So rough sawn is where, like I said, the edges are not um, they're not smooth, it's literally gone straight through, and that's where if you pick it up and you pick a piece of timber up and you see all the fibers are still sticking out, and typically that's when you end up getting like a splinter because it's still just been cut. Whereas if you get planed all around, so it's called planed or plain smooth, but like it does refer to as PAR sometimes, which is planed all around. So it's gone through a planer thicknesser, which essentially is a machine that has got almost like a razor blade esque blade on it, and you feed the material through on rollers, it'll go through and it'll literally just shave the very, very top layer off, and you can keep making it closer and closer together, and you can keep planing it down more and more, taking about a mil off at a time until you get it to the desired size, so you can change the thickness of it. But the main thing is, of course, that it then gets rid of any rough edges to it. Now that does cost more money because obviously it's more labour and you're using their equipment. So if you go to a timber yard, They'll give you the option of doing planed, but then they'll charge you more for it. So stock forms of metals. So metals could come in all different shapes and sizes. Typically, you get your sheets, and you can, like you can with manufactured boards, get different thicknesses of sheets. But then you've also just got different cross sections of material. So things like round rod, which is just like that solid rod of metal, and that's what you could then use for, say, if you're going to put something in the center layer to turn it. You've then got things like round tube that can be used in construction, same with square tube, angles and panels, hexagonal and square. So all of these are just different shapes you can use. Typically in construction, if someone's going to be welding anything like a metal fencing and things like that. So that's not a lot to cover with the stock forms of metals. Obviously, you can also get a bar of materials, like a bar of aluminium. If you're going to say do some like sand casting, where you're going to cast some metal into a certain shape, where you've made a mold, put it into sand casting, and then you're going to melt the metal and pour it. But that's where we would just buy a generic block of material, a generic block of aluminium or pewter or something like that. So the last one then is stock forms of papers. Now this, first of all, the key term to know is right here, which is grams per square meter, GSM. Now, what that basically is how you do identify the difference between paper and card or board. So when they're talking about card, they'll say both paper and board. So the magic number is 220. Anything that is less than 220 GSM, that officially counts as paper, and anything that is 220 and over is denser, it is thicker. That means that it's board, that is card. So for the first thing that comes to platforms, that's how you identify the difference. Now, if you've got a proper sketchbook, which you should have now, you'll have a look and it'll tell you the GSM on the back of your book. There'll be a little stick at the bottom left normally. It'll tell you what the GSM for the paper is. For example, the paper in that can be a lot thicker than, say, the paper that is in the printer in the classroom, the things off. So that would be a lot less than the GSM for your sketchbook. So that's the difference between paper and card. So then you've got the sizes. So if you've ever done art, or if you ever go into like architecture, you'll know you start off on quite big sheets like A0 or A1. And with this instance, obviously, the smaller the number, the bigger it is. And each time you're just halving it. So if you take A0, fold it in half, you end up with A1. Fold it in half again, you end up with A2. Fold that in half again, you end up with A3. Now, A3 is typically what we use in product design and design related courses at university, because it's quite good to sketch on. And then you fold it down, you get A4, which is typically is paper. A5, you have some sketchbooks that are A5 size. A6, we don't get a lot of use on, but it's quite good in craft and things like that. Then A7 and A8. Now, A8 is the smallest officially. That doesn't mean you can't make a smaller piece of paper. You could just cut that in half a few more times if you wanted, but that doesn't have an official name as the size. So I've got 5 questions for you there. Can you pause the video, give yourself 5 minutes, have a go answering the questions, and then we'll go through the answers. Okay, so question. So term stock form, what does it mean? So it's a standard shape or size that materials can be purchased in. Why are they used? For standardization purposes. So the whole point being, if you need to get some paper for your printer, you don't call someone up going, right, I need a piece of paper that's 170 mil wide and 400 mil long. You just go, right, I need some A4 paper. Or in construction, right, I need a sheet that's 6x4. No, I need a sheet that is 265 meters by 109. So you can start throwing random numbers out there. The whole point is you've got standardization, so you know what you want to order, you know exactly what's going to come. So examples of stock form paper, A1, A2, A3, and so on. On with that as well, so in the diagram on the left-hand side, so I talked about the A sizes. We do actually have bigger sizes than A. You have what's called SRA. So these are SRA 0, 1, 2, 3, and 4. So these are the much bigger sizes that you will find on things like billboards and bus stops as well. So we do have bigger than A0, but you would never come across it in normal circumstances. 2 examples of stock forms for wood, fluff sawn, plain squared edge, sheets, anything like that. And then 4 examples of stock forms of metals, sheet, bar, tube, hexagonal, plate, anything like that would be fine. So that is stock forms. If you've got any questions, please drop me an email and I'll do my best to answer them for you.